Hello, my dear students. Now, today we are going to discuss the ionic equilibrium, second part of the equilibrium, and our first topic is electrolytes. Electrolytes, you know that, which provides the ions, acid, base, salt, which provides the ions, which provides ions in the solution are called electrolyte. Electrolyte are of two type. Number one is that weak acid. Now we can say that electrolyte are of two type, strong electrolyte and weak electrolyte. You will define in this way: strong electrolyte and weak electrolyte. Instead of weak acid, you will say that weak electrolyte. In weak electrolyte, there are weak acid, weak bases, and salt of weak acid and weak base. In this way, you will define the electrolytes. Weak acid are, you know very well, that is the acetic acid CH3COOH, carbonic acid H2CO3. Weak bases are like as NH4OH, and salt of weak acid and weak base. Take any weak acid and weak base and make their salt, like as CH3COONH4. Ammonium acetate is the salt of weak acid and weak base. There are so many examples of weak acid and weak base. Boric acid is also weak acid. And now in strong electrolyte, strong acids. Strong acid are like as HCl, H2SO4, and strong bases like as NaOH. Salt of strong acid and strong base, salt of strong acid and strong base like as NaCl. So this is what, my dear student, electrolytes. Weak electrolyte are weak acid and weak base, and strong electrolyte are strong acid and strong base. In means of that, they dissociate into the water and give you the electrolytes, ions. Any solution that will give the ions, and electricity in metals, that is due to the electrons. The second part of this one is that acid base theory. First theory we will discuss here, Arrhenius acid base theory. Yes, dear students, now acid base theory, number one is Arrhenius acid base theory. This you know from the 10th standard. Acids are those which provide the hydrogen ions in the water, like as HCl, H2SO4, and bases are those which provides the OH negative ions in the solution, like as NaOH, NH4OH, and rest all are exceptions of this one, which are acid and base. Not only on the behalf of that, they will dissolve in the water and give the H plus and OH negative. For that, there are three theories. Second theory is that Lewis acid base theory. Lewis acid base theory. In Lewis acid base theory, according to this theory, acid are those which are the electron acceptor, and bases are those which are the electron donor. And you know very well that is ammonia has one lone pair, so electron donor. And acid is that like as AlCl3, BCl3, means of those compound which in which central atom has octet is not complete, and to complete their octet they are accepting the electrons. So these are the Lewis acid and Lewis base. Ammonia, you can say that. Cyanide, you can say that. So these are the Lewis bases. And next theory is that Bronsted-Lowry concept. Now look at Bronsted-Lowry concept. This is the conjugate acid-base theory. In this one, acids are those which are the proton donor, and bases are those which are the proton acceptor. Look that now when we will react HCl with water, we are getting that HCl is donating H plus and water is accepting that H plus. So what happened? Water has accepted the proton. So near it is what HCl is acid, and second case you will see that when we are reacting ammonia with water, that is 4 NH4 plus and OH negative. Here water is proton donor. So this is the water is there acid, and look there water is there accepting. So water is the acid and base both can react on the behalf of Bronsted-Lowry concept, and water is also having lone pair, so it can give the lone pair, so base is also, but water is not base. So there are three theories, different acid and base. So in the next topic we will do the electrolysis of water. Till then, goodbye. In this theory, he will put you the question, what is the conjugate acid base of HF? You will simply remove the H plus and F negative. So conjugate base of the hydrofluoric acid is F negative. He can give you so many questions, like as find out the acid or base of H2CO3. Whenever you want to get any base, remove the H, and whenever you want to get the acid, add the H. And this question is important, will come in the exam and asked number of times. Thank you, bye bye.